Let's take a look at section 2.2, square root of a function. So our first example, given g of x equals 3x plus 6, graph the functions y equals g of x and y equals square root of g of x. Identify the domain and range of each function and any invariant points. So our first step is to actually graph this y equals g of x, which is really 3x plus 6. This is a linear equation, and it's in slope-intercept form. So our intercept is 6, and our slope of 3, so we got 3 up then, and then we're going backwards, 3 down. And you should use a ruler to actually connect these lines. There we go, it goes on forever. And we should label this, this is y equals g of x. Okay, step 2, we want to graph y equals square root of g of x. Well, this is really to saying y equals square root 3x plus 6 is what we want to graph. Now we could make a table of values and graph this. However, we've already done half of the work. We already know from our graph 3x plus 6, or what that's equal to at every value of x. So then what we can do is we can actually just go to our graph and square root the height of each of these points to figure out our graph y equals g of x, square root of g of x. Now we need to pick smart points, points that we actually know what the root is. So perfect squares, so the root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and square root of 9 is 3. So we've got a radical graph now, and this is y equals square root of g of x. So actually we're all done at that point for graphing. Now next it says to identify the domain and range. So let's take a look at our g of x first. It's a linear equation. There's no restrictions on the height. It's continuous everywhere. So therefore error can be every x value. And the same thing for our y values, or our height. It can be any height. Now there is some more restrictions for square root of g of x though, because we can't square root a negative value. So none of this is possible to square root, which means that our smallest x value we have is -2. Now we can square root 0, so therefore we do include -2 as part of the set, and then this goes all the way to infinity. Now for our range, the smallest height we have is 0, and then the largest height is infinity. It goes on forever. Yeah, that's step 3 done. And finally, we need to identify any invariant points. So our invariant points happen at 0 and 1, because the root of 0 is 0, root of 1 is 1. Now, the first root invariant point is very easy to read off. We just have -2 comma 0. The second one isn't as easy. It's something comma 1. So we need to figure out what the something is. So we're going to let y equal 1. And therefore 1 equals root of 3x plus 6. So we're going to square both sides. Then we're going to subtract 6. And then divide by 3. So therefore, our invariant point is 5 over 3, or -5 over 3, comma 1, and -2, comma 0. So then make sure this is clear. This is our invariant points. Let's take a look at example 2. Using the graphs of y equals f of x and y equals g of x, sketch the graphs of y equals square root of f of x and y equals square root of g of x. Alright, let's start with f of x. So this is a nice linear equation already graphed for us. We just need to take the square root. So we're going to square root the height. Again, we can't square root a negative height. So therefore, we'll pick perfect squares of positive perfect squares. So square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. And that's as far as that graph goes. So we're going to connect our points, and we get y equals square root of f of x. Again, we cannot root a negative height, so this part's not going to be part of our graph. Next, y equals square root of g of x. Now this is a parabola this time, but it's the same concept. We cannot take the square root of a negative height. So we're going to find perfect squares. So square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and we're going to get a nice radical graph. The difference here, though, is the parabola does have a second part where it's positive heights. So again, square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. And again, connecting those lines. Now we should label this. This is y equals square root of g of x.